Okay, good afternoon, everybody, or I guess good morning, depending on what time zone you're in. This is AP Computer Science A, and welcome to String Week. We are kicking off String Week today. My name is Rob Schultz, and I am from Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerland from Hoover High School in Hoover, Alabama. We're glad that you're with us. Here is our map of APCSA exam reviewers, and we hope you find yourself somewhere on here. You could be under our cluster in the US, or we have somebody from South Korea with us now, and there are probably lots of people from all over the place. These are the people that we know of who've sent us something. And I added another pin in India, and then we have Puerto Rico and El Salvador, and then Bo and JJ and Jill and Rob. So welcome. Here is information about the exam. Your date is May 15th for the regular exam. That's the day that is recommended. You'd need to have a serious extenuating circumstance really to think about postponing. Question 1 will be either an array question or an array list question, and you'll have 25 minutes, and that's the large majority of the points. You know, right about 2/3 of the points, I guess you'd say mathematically, or close to it. And then question 2 will be methods and control structures, and have less time. It's also worth less weight. And together, I thought that we would talk about, Mr. Schultz and I, this wonderful question that we got from Nate in our mailbag. You can definitely send us a question like this. We also got a different comment that I'll talk about later, actually, too. But from Nate, hi, Mrs. Westerland, Mr. Schultz. I wanted to ask you both a question. Does the code I submit have to exactly match what's written on the answer key to receive points? Also, do you know what percentage we have to get correct in order to get a 4 or a 5? So together, we can kind of put together our thoughts on this question. Question part A, does the code I submit have to exactly match? The answer to that is no. You do
Absolutely
have to
not.
have working code, but as long as you have a valid solution to solve the problem that is not excluded, which you wouldn't know that, then you can get points for your solution. And there's typically, I don't know, 6, 8, 10, 12 answers. You want to talk about that for a second, Rob, about
You know, when you go out and look at the College Board website, you see under the scoring guidelines what the chief reader. There's one person that's assigned the role of chief reader, and they kind of oversee the reading process. And part of what they do in cooperation with the development committee when they put the exam together is they create what they call that canonical solution. I don't know whether it's meant to be the most common solution or the most efficient solution. You know, it could be one, it could be the other, but it's the one solution that the chief reader submits as the canonical solution. But you know, anyone that's ever attended the reading will tell you that we will get dozens of different solutions that actually work. So, you know, I tell my students all the time, anytime I give you a larger problem, there are 1,000,001 different ways that you could put a solution together. And the goal is to try and find the most efficient solution and the cleanest solution. But when it comes to the exam, as long as it's a solution that works and someone can actually trace the code and show that the solution that works and produces the correct output, you'll get full credit for it.
Yeah, and that's part of why we keep prompting you and spurring you on to write code, follow up with the code, sample code that we're giving you, practice it this way, take notes that way. You want to kind of come at these things from a variety of standpoints to get to the solution that you're going to produce on May the 15th.
Yeah.
And then this, go ahead.
Oh, I was just going to say the one other thing that I was going to throw in, and Mrs. Westerland will make a reference to it here in a minute when we talk about the AP subset. You know, usually I recommend to my students that they try and stay within the subset, but if there are things that you're familiar with that aren't part of the subset, that's fair game too, as long as it works and does what it's supposed to. But if you step outside the subset, you just have to be careful that you're doing things correctly, because then your solution might not kind of match up with the points the way they're laid out in the rubric, which means if you go outside the subset and you make a mistake, it could cost you a point in multiple places. So I always try and recommend staying within the subset when you can.
Yeah. Second part, do we know what percentage of the exam you have to get correct in order to get a 4 or a 5? So no, specifically no, this year's going to be different. After the AP exams this year, each subject will be reassessed based on this year's exam and the weights and the rubrics for this year's exam. This year's going to be a special year where the cut scores, if you want to call them that, will have to be calculated for this particular year. So, I like to tell my class that pretend like you have, in our case, two ladders, a ladder for question 1 and a ladder for question 2. You're climbing a ladder to earn points on both questions, and you want to climb those two ladders to the highest point that you have the ability to climb. And that's just sort of how it's going to shake down. But it'll be a little different this year, so don't spend a lot of time worrying about, in past years this has happened mathematically in this course or that course, because we're given different kinds of exams in 2020. All right. Anything else you want to say about?
Yeah, I guess the last thing I would throw out is, we're still learning more about the exam as we go to, and as we get closer to the exam time, in the 2 weeks before the exam, we're hoping to do specific review and exam prep, and hopefully we'll be able to give a little more information. Now that the second question here, what do you need to get a 4 or a 5? We won't know that until after the exam. But questions about the exam and format of exam and how to submit the exam, we'll be able to answer those hopefully as we get closer to the exam and we get more information. So great questions, Nate. Keep
I
them coming.
know. Love it.
Yep.
Yeah. So, like Mr. Schultz said, we're on string week, and today we're going to talk about string objects. We're also going to finish the horse barn question, free response from Friday, that has to do with arrays. And we're going to talk a lot today, hopefully, and lap on into tomorrow with the Java quick reference. So you can see our layout of the week, and I'm going to kind of give it to you back in my analogy. Java is like the Pacific Ocean. It's this vast, large thing, programming language that's used all over the world. It's dynamic, it's growing like the Pacific Ocean. We've scooped out a swimming pool size amount of content that is made up of what we call the AP subset, what College Board has said that students are responsible for. And that's formed our lanes. And I've added this week that you are going to be now in the string class lane. We're going to be on the string class all week long, swimming back and forth. But that really has a lot of carryover into methods and control structures. It's hard to do something with a string that doesn't also, a part of that would be building a method or working with a control structure. So those are the 3 things that we're doing this week. And we'll probably also touch on arrays and array lists. It's just hard at this point to get to cut all these things apart.
Yeah, we'll definitely see things pop up, especially as we look at the practice free response questions, that the lanes overlap, the water drifts from one lane into the other. So yeah, to kind of go with that analogy, we'll definitely be dealing with arrays and array lists and things as we look at strings with the free response questions. So
please remember to take notes, go back and watch the videos, pause. I'm making y'all some sample notes, but you need to be making your own notes. So Mr. Schultz is now going to finish up horse barn with you. And after that, we're going to come back and talk about 2.6 string objects.
Okay, I'll tell you what, it is not letting me steal the screen. So would you mind unsharing? I don't know, I should be able to steal it, but it's not letting me do it today. There we go. Yep, that works. And then I will pick up the slides from there. All right, so in our warm-up, so last week we started the 2012 question number 3, the horse barn question. We went through part A on Friday. So if you haven't seen the first part of the question or the description of the question, you might want to pause now if you're watching this after the fact. If you're watching live, you might want to go back and look at it later. But I'm just going to jump straight into part B, where we have to consolidate our horse barn. So the idea is to take our open spaces in our horse barn and consolidate so that all of the horses are moved down to one end of the array, and we have all of our null spaces open at the other end. And I'm going to kind of approach this rather than what I've done in the past where I kind of piece through the code one point at a time. I'm going to show you all of the code, and we're going to kind of look at it from a tracing standpoint, because we haven't something I try and do with my own students as we have time is actually look at code and trace through and figure out what it does. So I thought this might be kind of a fun one to trace. So again, the idea is that we're moving Silver, Lady, Patches, and Duke down so that our two null spaces are up to the right-hand side. And again, if you remember what we looked at on Friday, we looked at insertion sort, where we had to slide elements of our numeric array to the right and then insert things in their space. So this is kind of similar to that. We're talking about sliding things around in our array, okay? So tracing through this, we start by going into our, I forgot. One of the things I tell my students do when they're tracing code is just to make sure that you understand where all of the loops and conditionals start and stop. I usually ask them to very lightly kind of sketch it off to the side, just a little bracket that shows where things begin and where things end. And that way I know where my for loop starts and stops. I know where the if statements and all the for loops and all that good stuff kind of start and finish. So again, it's just kind of a helpful skill as you're tracing through code. So now as we start to trace the code, I'll make a little column off to the right-hand side for my I variable, and I'll set I equal to 0. 0 is less than spaces.length, which is 7. So we'll step down into the for loop. And our very first if statement says that we're checking to see if the contents of position I, which is 0. So if the contents of position 0 is equal to null. And in this case, it does not equal null, it equals trigger. So we're going to skip the if statement. We're going to cycle back to the top of our for loop and increment our loop control variable I to 1. And now we're going to go into the for loop and start all over again. So in this case, the value at position 1 is equal to null, which means we go into the if statement. We're going to declare a new variable, and I want you to pay excuse me, I want you to pay attention to scope of variables. I mean, that's kind of an idea that we need to look at because J is being declared inside the parentheses for our for loop. Its scope is only the for loop. So we're going to declare J and set J equal to I plus 1, which is 2. In other words, we're only looking to the right of whatever value we're sitting on for I. We're going to come down, and because the value at position J is not equal to null, that's a true statement, we're going to go into this if statement and we're going to start sliding things around a little bit. Okay, so the value at position 1 becomes the value at position 2. The value at position 2 becomes null. And because we really don't want to go any further than that inside this if statement, we need to jump out of our for loop. And again, our goal is to stay within the subset. For this example, I'm keeping us within the subset. So the way we would do that is we would set the value of J equal to spaces.length. So this condition would no longer be true. Now, if by some chance you're familiar with the break statement, again, kind of going back to Nate's question, if you used a break in here to break out of the for loop, that would be perfectly fine. But the break statement isn't part of the AP subset, and that's why I wanted to kind of keep with the AP subset for our example. So, okay, so at this point, J would be set to 7. We're going to come back to the top of our for loop, and we're still going to end up incrementing J again. J now has a value of 8, which is not less than spaces.length. So we'll jump out of the for loop. We'll get to the bottom of the if statement. We'll end up cycling back up, and we'll increment I again to 2 and kind of keep working our way through that way. Okay, so the value at position 2 is equal to null, which means we go into the if statement. We redeclared J. J now has a value of 3. The value at position 3 is not equal to null, so we kind of repeat this process. The value at position 2 becomes the value at position 3. Value at position 3 becomes null. We set J equal to 7 again, our length. As we increment, now we get 8. 8 is not less than 7. So we're going to come back down again and we'll increment I one more time, and now we're at 3. And notice what happens now that we've got 2 nulls up here. Okay, the value at position 3 is equal to null. So we're going to redeclare J. J now has a value of 4. We'll come down into the for loop. The value at position 4 is equal to null, which means that this condition is false. So we'll skip the if statement and we'll increment our inner for loop again. So now J has a value of 5. And we'll look and see if 5 is not equal to null. Well, now it's a true statement. So I'm actually sliding Patches down 2 spaces. The value at position 3 becomes the value at position 5. The value at position 5 becomes null. We set J equal to 7. And that process just kind of keeps repeating. So because I figure at this point we kind of have the idea, I kind of sped up my demo here a little bit. So now I equals 4. 4 is equal to null. So we're going to go into our for loop. We're going to look at position 5. Well, 5 is null and position 6 is not null. So we need to move 6 down to 4. And we're going to set 6 equal to null. And then at this point, we'll increment I to 5. Well, even though I is the value of position 5 is null, we're not going to find anything above it. So we'll cycle through this for loop and not find anything. And then we'll move I up to 6 and we'll cycle through and not find anything above it until we get to the point that the value of I equals 7, which is no longer less than spaces.length. Oops. So we end up jumping out of our for loop and we've accomplished our task. All of our horses have moved down to the front end of our array and all of the null spaces are at the back. So how did everybody do? How did you do with free response question part B? Hopefully everybody did well.
Hopefully good.
So.
And I was going to throw in from Miss Romchek in Dallas. I've heard her explain horse barn, and a different way to solve this problem, it would be to create another array and put all of the horses who have names in the new array. So like take them out almost, she calls it, to another pasture, and line up those horses. And then once you get them lined up, bring them back into the array in 0 to 4 order, I think is what it was. And then the nulls go to the end. So there are multiple ways to solve the problem. It just needs to be a valid solution that would work for the test cases like you're given in the examples.
Absolutely. Okay, so I will turn things back over to you.
Nice.
Mrs. Westerlin is going to pick up from here and introduce us to string literals and string objects and concatenation and all kinds of fun stuff. Do I need to stop sharing again?
I think I might can grab it. Let's see here. Okay. I'm going to scoot down past all the horses. Mr. Ed's what we should have called that. Y'all are too young to know about Mr. Ed. Oh, I didn't scoot down. I still didn't go down. But I'm barely old enough to know about Mr. Ed. It's more my brother's age. Okay, so string week, welcome. The only thing you really need to know about for string week is about data types, a little bit about that. And what you're going to learn today is just a small lesson. Today is almost like part A of what B is going to be tomorrow, but we had split these into days, and I may lap forward just a little bit. Our goal between today and tomorrow is to learn about how to create strings in a variety of ways, how to concatenate, and how to use the methods in the subset. And then I'm going to tell you a few others that I think that you should learn now that you have plenty of time. So that's kind of our goal. So here are the data types. We looked at this last week, and I can't see over here. Let me get this. The data types that we're dealing with within the subset. And particularly today and tomorrow and this week, we're going to be camped out on strings for the most part. So if we make a string object and we don't define it, just remember that it's going to be null. That's kind of the moral of this story. Here are two operators that I want to expose you to that I'm going to show you today. We're going to talk about concatenation, and that's this word right here. If you've used Excel, you might have used equal concat, which I tell my class is almost like doing math with words. You know, you may have a field in a spreadsheet that has first names and a field with last names, and we really want them merged together so that we can do something with them as the person's whole name. So we can do equal concat and add those together. We're going to do the same thing in Java, except that we're going to be using strings today to do that with. Y'all have probably concatenated a lot in system.out.println statements where you've added different components together to produce a println statement. We'll do some of that today too. But I want to show you how you can create new strings using other strings specifically. And I added a comment here at the bottom. You're going to want to spend some time this week in CodingBat. CodingBat has 3 sections on strings. Strings 1, strings 2, strings 3, which they call hard strings. Get yourself involved in those this week because that's really going to help you quickly hammer out code related to strings. And all of these little bitty details are going to give you the skill sets that you need to be able to respond in a timely manner to the free response. So that's what we're looking at there. All right, I'm going to switch now to my little projector and show you some things about strings. And hopefully, yeah. All right, let me zoom in a little bit. Okay, so I have all these strings on my board here. And a couple of points I want to make, and then I'm going to show you the syntax. So what I want you to think about with a string is, let me move this. I want you to think about the fact that this would go on, so let's just pretend like I take it off here and it's going on and on and on. I have all these different kinds of strings. This one's really long. These are all the same data type. They're just different strings. So, and the reason that I chose them, these are all knitting yarns of mine. I love to knit in my spare time, which, you would think that during Corona I'd be getting a lot of knitting done, but I don't know what else I'm doing. I'm just twiddling away the hours, seems like. So we have all these strings. So in Java, we have really 2 or 3 ways, I guess technically 2 ways to create a string, but we can also create a string from another string. So I want to show you the syntax of it, and then I want to show you about concatenation. So one of the ways that we can make a string is first we have to declare, I don't know if y'all can you see that?
Yeah, that's in.
Okay, good.
Yeah,
All
we're
right,
okay.
so first you have to declare your data type, string, and I'm going to call this one, I'm going to try to use something different than what I've used before. I'm just going to call it S1, and it's a new string, but I'm going to make this string maybe short, probably. Let's see, I'll just use today's lesson is 2.6 strings. That way it's kind of short. All right, so that's one way to make a string. Second way to make a string is if we want to do a string what's called literal, where we declare the string. I'm going to say an easy way to think about this one would be to think about making this string almost, this one is actually creating an object out of a string, because remember we're using right here the word new. If we make a string literal, it's not the same thing. It is a string, but it's not the same thing as, and I'm going to do, this is a literal. I have a note over here to myself because I wanted to make sure that I told you to use string literals are stored in the string pool. They're not stored the same way that an object string is stored. So when we get tomorrow into methods, particularly when we look at dot equal and dot compare to, a string literal will outcome differently than when we compare string objects, because of the fact that this string lives in the string pool as opposed to being given an actual physical and reference location. So just kind of bear that in mind as we go forward. All right, the third way I want to show you about creating strings is if we make a third string, we can actually create this next string. It also creating it with the instantiator new, but when we make this string, I'm going to call string 1, and I've made a new string, string 1, as my parameter to string 3. So string 3 is going to pick up and duplicate the contents of the object that is string 1. So you can almost think about it as this one is going and grabbing this object, but it's creating a new version of it. So string 3 is different than string 1, but they actually have the same content at this point. Now, all of those are creating strings. Another way that we could create a string would be to concatenate a string. So it's similar to this one, and I'm just going to like abbreviate down here. We could do string 4, and it would be, again, a new string. But I could make this one be, let's just say string 1 plus string 2. And again, I've created a new string, and I might want to put that like that. This is a new different string, but it's adding together, concatenating together these two different string objects. So all of that's good. So that's one thing. Now I want to show y'all what will happen if we wanted to take maybe part of this string or all of this string and add it together with something else and create a string with the plus well, we've already used the plus, but the plus equal to. So here's how you're going to do that. So you would do string, and we're just going to keep with our numbering system here. String S5 equals new string. And then I'm going to leave this one empty. And then on the next line, I'm going to redefine string 5 with plus equal to. Now in the math setting, y'all are familiar with using this as an incrementer. It's going to add to and redefine. So it's going to do the same thing with our string work here. So for this one, let's just do string 1 plus, and then I'm going to put in, that one said 2.6 strings. Let's add in some text here. Is, and then we'll just add, we'll grab string 2 since that's all we've got to work with. We don't have a lot of options to work with. So using the join and redefine, we can add together two objects, and if we wanted to, we can add some text to them. Now I wanted to show you an example of kind of how this looks, especially this one right here and this one right here, how these might look, because it's real easy to think about that this one is a string all by itself. And I don't know why they named it string. I actually thought this morning I should look up, maybe we could see, and you know, Sun Microsystems or Oracle or somebody would tell us, why did they call it a string? I mean, I'm guessing it's because maybe it's a continuous line, goes along forever, made up of characters. I don't really know. But almost like an array, well, definitely like an array. Our string can be really long as we need it to be, but you know that in the reality of life, we typically have, you know, normal size strings that are sentences. You know, you're not going to type your term paper in Java. You could, but please don't do that. So that's how those might look. But when we get down here to this situation where we want to take bits and pieces of strings and put them together, or even this situation right here, here's how this would look. So on this one, I'm taking a piece of this string. Now, I'm not destroying this string. I'm almost doing like copy and paste. Give me this one and bring it down here, but it's coming in its totality as a new object. I guess I should turn it this way, shouldn't I? So that my colors line up. And then I'm adding it together with the concatenation operator. And then here I might I could bring in a different string, and then I could add it together and bring in another string. That's really what you're doing when you add those together, is you're joining those things. So that's one part of today's lesson. The next part I want to go to, and this is a little bit of a look ahead to tomorrow, is about the indexing of strings. So when a string is indexed, and I need one of my little knotted ropes back. I'll get this purple one because it's got a lot of knots. And maybe I'll get a clean sheet of paper. So when a string is made, I'm just going to come underneath this one right here. So this string, 2.6 strings, is actually going to index exactly like you learned last week that an array indexes. And notice there I have a little a period or a dot. That's going to count. And then 2. And then the space bar right there is going to be 3, 4, 5, 6, 7, 8, 9, 10, 11. So all the way out here to the period that I wrote, that would be my 11 indexes of this string. Now, what I punched out of this from my former life, once upon a time, I scrapbooked all the time too. I'm like, you know, a hobby person, I guess. I want you to think about the indexes of this string kind of like these squares, and this will give us a little jump start to tomorrow. And then we're going to move on to kind of what I want y'all to do tonight. So each one of these would be, this would be the 2, 2.6, and I'm going to put an underscore for the space bar, even though it's not an underscore, you know that. And I would need more. So I want you to think about that, just like you learned with arrays, a string is indexed similarly so that each item is in its own slot. And the reason that this will be an issue tomorrow is when we look at the methods for strings, particularly the method where when we want to just grab or evaluate one letter of a string, one alphabet letter, one item in a string, and you're using a particular method, the substring overload. Being able to count these will be useful. So tomorrow we're going to kind of pick up when we look at an unplugged version, and I'm going to keep this just the way that it is. So I want you to hold that thought. So thinking about tomorrow, I'm going to kind of bounce ahead since I already have the projector going. I want to look at the Java quick reference, and y'all can see you're not seeing double. My home printer is kind of janky. It tries to print a shadow behind everything, but the Java quick reference is the document with all these things that we keep talking about are in the Java subset. So it would be great if you either can print a copy, you may still have a copy that your teacher gave you, or what I need you to have for tomorrow is really just this section. So you could actually handwrite this. You're going to need the whole sheet of paper at some point, but as we go toward May the 15th, you've got plenty of time. So don't panic if you don't have a printer at home. You know, sometimes I have no ink. I happen to have ink now, but you know, you've got about a month and a couple of days to get this sheet of paper either reproduced or produced. And you may already have one, like I said. But these are the things that we're going to be going over tomorrow. There's a couple of more, like I told you, that I'm going to add that I really think that you have time to learn that will make approaching free response maybe a little bit easier. There are a couple that will be helpful. So tonight I want you to obtain a copy of this or write it out so that you'll have it, so that we look. Now, the other thing that I wanted to go over before we change and switch gears is the fact that strings are immutable. That's our other vocabulary word of the day. And that kind of goes back to this example here that I gave you, where I said that when we created this string down here by concatenating these together, we did not destroy string 1. We didn't change string 1. We grabbed that whole thing. Even if we had gone in here and grabbed just index, I don't know, 9 through 11 and just picked up the G and the S, we wouldn't have changed S1 because it's immutable. It's unable to be changed. So we can grab from it and we can use it, but we're not going to alter it. And the best analogy for thinking about the word immutable is to think about Teenage Mutant Ninja Turtles. They actually mutate or change. Strings are not going to mutate or change. We can reach into them and grab things, but we're not going to change them in terms of their composition. So, all right, now I think that's all I wanted to cover today. I may pop over to JGrass. Let me see what time it is. Maybe. I want to show you some of this in JGrasp if I can. I think I have enough time. If you start noticing the time's getting crazy, Mr. Schultz, let me know. Can
Okay,
y'all see my JGrasp?
you're doing okay. We got about 10 minutes left.
Okay. All right, because the tip of the day is fast. Okay, so I've made some strings here. They're different than the strings that you had on the screen on the unplugged. created a literal, created one as an object, created another one as an object that I grabbed. And the next thing I wanted to cover that's a part of today's lesson, and it was going to be hard to show you this on the unplugged version. The unplugged version, I really wanted you to get the concept of how a string, I want you to have that in your head, of how it's treated. It's a continuous line. Okay, so you see how to do print statements. Y'all know that already. Here's what I want to cover about escape sequences, and this gets us into our tip of the day about making a snipping tool image. So escape sequences are ways that we can print things using the backslash key. Backslash is above enter and below backspace. It's about 2 spaces down from the P as in Paul key on your keyboard. So if you wanted to print a character that typically we use in Java for special things like an actual backslash, or a single quote or a double quote, because in Java a double quote signifies a string. So if we just type a double quote, it's not going to want to print us out a double quote. So there are a variety of escape sequence keystrokes that all have to do with calling them via a backslash that will let you do special things. Backslash n will create a new line. Backslash T will put in a tab. I don't have a lot of them committed to memory because it's just not something that I do every day. So what I thought I would do to demo for y'all, here's the code to create some of them, and then here's what comes out on the bottom. You can see the result of here's the backslash n that's a part of my string, but when Java sees that together, it created a new line. To display these double quotes down here, you see where my mouse is pointing? I had to type backslash quote. To get a single quote, I had to do backslash single quote. So that's really what's meant by an escape sequence. So the concept of an escape sequence is a part of lesson 2.6. So what I want to demo for y'all is how to let's see, make a snipping tool. So we're going to come back in just a minute and do that. So I want you to hold that thought, but I want to go through and finish out this lesson before we move forward. All right. Here is JDoodle code for today's lesson, and there's actually some other code down there too. So I would love for y'all to take time, add more strings, concatenate some strings, use the plus equal sign, join and redefine concatenation option in this code. All right, here is a quote from Serena in Austin, Texas. I thought that was really appropriate for today.
That's cute.
She sent
I
that
like
in.
that.
I know she sent it in Thursday or Friday. So I wonder what 5 languages she knows. I'm trying to think. I mean, most kids might know Python and I don't know, maybe C# if you did some web design.
Yeah, maybe C++ or
Yeah. So
Visual
I don't
Basic
know.
maybe.
Keep
Yeah.
learning languages,
Very good. Yeah.
I know. Thought that was cute. Okay, so here are some strings that are similar but different than the ones that we had today. So what's happening on this line that I have the red box around? We're creating a new string out of an existing string by the parameter being a string object that we're calling. So str30 is its own new string object, but it's going to bring in str10. All right, here's a concatenation version. So string 40 is going to be 10 and 10 joined together. And you may be thinking ahead, that's not going to look very pretty because there's no space bar added in between. So if you wanted it to look nice, you're going to have to do something else with it. String 50 is not null. It contains 1 space bar. But string 50, what's happening there? I hope you said in your head that it has a tab. This is an escape sequence for a tab, so it's going to move you over. Then it's going to pull in string 10, and then it's going to create a new line. Next one is this one. Same deal, created with Redefine. And then I had a statement to print it out. So now let's talk about our tip of the day. And got about 6 minutes. Okay, so we do not know. This goes back to not Nate's question, but Alan wrote in and said, asked some questions and left a comment about the submission for this year's AP exam. We do not know, Mr. Schultz and I, exactly how you're going to turn in your code that you write on May the 15th. It might be that you handwrite your code like a typical year and you take a photograph of that code and you upload it somehow. Since in the instructions there's a mention of an IDE use, it might be that you could type your code in JGrasp or JDoodle or Notepad or Google Doc or something and make an image out of that. So we do not know. But regardless of how you turn in your code, whether it's handwritten or typed, using the snipping tool we feel like is a life skill that might be helpful on May the 15th, but it will definitely be helpful at some point in life. So this week we're going to show you each day a different way to use snipping tool depending on the device that you have. And today is going to be the Win PC. So I'm going to pop over and share my screen and show you how to use snipping tool. Snipping tool is a part of Windows. So let's just say that I wanted to make a snip of this escape sequence code. So I have something on my screen that I want to make almost like a screenshot on your phone. And y'all are familiar with on your cell phone. I want to take a screen capture of this Snapchat because it's going to go away and nobody's going to believe what this picture looks like. You've all done that. So you would go to the start in Windows and just start typing snipping tool, SNIP, and it comes up. Now I already have it open, so I'm not going to open it again. And I tell it I want a new snip.
Now you might need to change your share because we're still just seeing
Oh,
your
are y'all
JGrasp
not
screen.
seeing it?
Yeah.
Oh, I wonder if it's not going to let me show.
You might have to change your share
How,
so it shows your desktop.
can you see? I know you can see snipping tool right then.
Yeah.
Let's see. How about this? How about that?
There you go.
Oh, yay.
That's it.
Okay. So I have on my screen what I want to snip, and then I open snipping tool and I click new, and notice that everything grays out. So whatever I drag my mouse over is going to be what is snipped. And watch, it's going to grab. I'm going to get my eyes. That'll be kind of weird. And I'll make it a little bit smaller. You might be able to see. So whatever is right here is my snip. So from snipping tool, I could immediately save this as an image, save it as a variety of different file types, or I can print it. My printer also likes snipping tool prints better than some other kinds. Like I said, my home printer is kind of janky. Or I can copy it and paste it somewhere. So it's super easy to use snipping tools. So if you have a PC like a Windows PC, look for snipping tool. There are some web applications that do the same thing as snipping tool. I had a guy in my class a couple years ago and he used something that started with a Z, I don't know. That was basically snipping tool, but he just liked to find a different application than the known and be his own person. So you might want to do it that way. So there's that. You can definitely save it, like I say, copy it and make it an image, and it's really a nice way to grab something. So tomorrow I'm going to show you how to do snipping tool for Chromebook. And then the next day, I'm going to show you or tell you how to do it on a Mac. And then, no, Wednesday, we're going to talk about phones. And y'all already probably know that. And then on Thursday, how to accomplish the same thing on a Mac. And you can get 15 steps ahead of us and know how to do it before we even get there, because we just feel like that this is going to be possibly a skill that will be helpful. We don't know. We just want to make sure that y'all are as equipped as you can be. So here's our debrief. String is a class. String objects can be created by declaring a literal, calling a new string constructor, and that can also include when you call the string constructor bringing in a known string, an already defined string. They're immutable, so they're not going to be changed. We can use them, but we don't have to mess them up in order to use them or tear them apart. They can be concatenated, primitive values can be added, escape sequences start with a backslash. So tonight your homework is to acquire a copy of the Java Quick Reference, and it's in the folder in your Power Up for today. It's available also through the CED. It'd be great if you got into Runestone and practice it. You can jump ahead and start working on coding that. So that tomorrow you're prepared to work on the methods. Look at this bunny from Idaho.
Oh my gosh.
I know. At first I thought it was a cat, and then I was like, that's a bunny. It's the fluffiest thing, and I've never seen those kinds of ears. Anyway, so fascinating. And then all the way from, I think, India, we have somebody's My CSA workspace. So that was kind of fun. And then you see the cat and the dog. So we have some interesting and cute pets to share this week. Okay, go ahead, Mr. Schultz. I'm just keeping on rambling. Sorry.
Nope, that's okay. So just a quick reminder, if you are in AP Computer Science Principles as well as AP Computer Science A, or if you have friends that are in AP Computer Science Principles, remember that Mr. Bonarigo and Mrs. Alano have been putting together some videos through College Board that your friends or you could go out and find through YouTube if you need maybe some more explanation of some of the performance task questions that you might have. If by some chance you are having device or internet access difficulty, please make sure to go to cb.org/tech to let College Board know. I know that they are taking some pretty big steps with some partner companies that are trying to help get technology and internet access to students so that they have an opportunity to be successful in the exam. And we kept you a minute or two late today. Glad you guys stuck with us, and that's really all we have for today. Tomorrow we're going to dig more into string methods, and we'll keep building from there.
Have a good day, everybody.
Everybody have a great day.